Hello everyone, Jai Hind to all. Welcome in Digital School of Ajay Kumar Garg, Engineering College, Ghaziabad. In this video lecture, I am going to discuss about a topic hashing. This is the outline of hashing, definition of hashing, types of hash function, basic operation on hashing, hashing components, data structure, what is collision, and what is the techniques which is used to resolve collision in hashing. This is the most important topic of unit 2nd. Now, first we want to define what is meant by hashing. Hashing is a popular technique for storing and retrieving data as fast as possible. The main reason behind using hashing is that it gives optimal result as it performs optimal searches. That means if we want to search an element, then by using minimum time, we have to find the given element by using hash function. The second point is hashing is a technique or process of mapping keys and value into the hash table by using a hash function. Hash function is a mathematical function by which we have to sort the given element or search a given element in a efficient manner. The third point is it is done for faster access to element. It is a efficient and faster algorithm or methods which is used to find the element. The efficiency of mapping depends on the efficiency of hash function used. That means if we use a more efficient hash function, then the efficiency of algorithm is also high. Next point is this method is generally used the hash function to map the key into a table which is called hash table. This is the most important point. We map or retrieve the data according to the hash table. Now types of hash function. There are three types of hash function. The first one is division method. In case of division method, in this method, the hash function is depend on the remainder of a division hash function is defined by h of k equal to k mod m. That means we have to define the key value. If we have the key value is 20 mod 3, then the output value of this expression is 2. That means the value 20 is stored at location 2nd. Mod return the remainder of the given function. Next method is mid square method. In mid square method, firstly the key is squared and then mid part of the result is taken as the index. Hash function is defined as h of k equal to I. By using this function, we have to store the given keys into the data structure, where I is obtained by deleting digits from both the end of K2. We empathize that the same position of K2 must be used for all the keys. Next is digital folding method. This is the third method of hashing hash function. In this method, the key is divided into separate parts, and by using some simple operation, these parts are combined to produce a hash key. These are the functions which are used to find the location of data into the data structure. Truncate the address up to digit based on the size of hash table. This is the main function of digital folding methods. The next is basic operation. In the basic operation, first operation is hash table. This is the main data structure in which we have to store data or retrieve data from the given table, and any operation which may be put or apply on the given hash table. This operation is used in order to create a new hash table. That means we have to create a new data structure by using hash table method. This is our next operation which called delete. Delete means removing information from the given table is called delete. This operation is used to order to delete a particular key value pair from the hash table. Next operation is get. This operation is used to order to search a key inside the hash table and return the value that is associated with that key. That means like searching, get function works similar like a searching method. This return the value according to key value. The next point is put function. This operation is used in order to insert a new key value pair inside the hash table. That means if we want to insert a value in a hash table, then we have to use put operation. The next one is delete hash table. This operation is used to order to delete the hash table. If we want to delete whole table, then we have to use delete hash table operation. By using this operation, we have to delete all the entry of the table. Now we have consider an example how the hashing is executed or stored inside the hash table. There are hashing component. There are two hashing component. The first one is hash table and second one is hash function. Hash table is a space or location where we have to insert or retrieve the data. Now we have taken a example of hash function. Let hash function is hx, map the value at index x modulus 10. This is the hash function. That means hx equal to x modulus dividend 10. This function is used to store the value inside a table, and table is in the form of array. For example, if the list of value is 11, 12, 13, 11, 12, 13, 14, 15, it will be stored at position 1, 2, 3, 4, 5. How this key's value is stored at this position, this is shown in the next slide. In the array or hash table respectively. How this value is stored by this index, we show in a diagram. Look at this picture. This is the list of array 11, 12, 13, 14, 15. We want to store inside a array. The array is called hash table. This is the name of array. Now we have to take an array of size 6, 0, 1, 2, 3, 4 and 5. Now we have to compute mod of the given keys. Mod is calculated like this: 11 mod 10, or we have to write like this: 11 mod 10. The value of this expression is 1. That means 11 is stored at the position 1. Look at the table. Here this is the position 1 and we have to insert 11 at this position. Now we have to compute 12 mod 10. The value of this expression is 2. That means 12 is stored at location 2. 12 is stored at location 2. Now compute 13 mod 10. The output would be 3. That means 13 is stored at location 3. When we have to compute 14 mod 10, the output will be 4. That means the value is stored at location 4th. And now 15 mod 10, the output will be 5. That means 15 is stored at location 5. This is the method through which we have to show how the value in our hash table is stored. Using this hash function, we have to store the different element at the different position. Here we also show how the value is evaluated. This is the 12 mod 10, this is 13 mod 10, this is 14 mod 10, and this is 15 mod 10. Now the next point is collision. Collision means if we want to store an element at a particular position and that position is already occupied by a different element, then we can't insert the given element at that position, and this situation is called collision. Means if we want to store an element at a position already occupied, that condition is called collision. Since a hash function get us a small number for a big key, there is possibility that two key result is same value. The situation where a newly inserted key map to an already occupied slot in a hash table is called collision and must be handled using some collision handle techniques. For removing the collision, we have to use collision handling technique for remove to collision for a given data. Following are the way to handle the collision. This is a chart in which we have to show how the collision is classified into different category. Collision resolution technique divided into two parts. The first part is separate chaining and second part is open addressing. Separate chaining is also called open hashing and open addressing is also called closed hashing. Closed hashing is divided into three parts. The first one is linear probing, second one is quadratic probing, and third one is double hashing. This classification is on the basis of hash function. If in case of linear probing, we have to use linear hash function. In case of quadratic probing, we have to use quadratic function, and in case of double hashing, we have to use double hash function. The output of first hash function is work for the input of second hash function. Now the first point is chaining. The idea is to make each cell of a hash table point to a linked list of a record that have same hash function value. Chaining is a simple but requires additional memory outside the table. This method is used also to identify the element, but there is a need of extra memory in case of chaining. The second point is open addressing. In open addressing, all elements are stored in the hash table itself. Each table entry contains either a record or nil. When searching for an element, we examine the table slot one by one until the desired element is found or it is clear that the element is not in the table. This is a two methods. The first one is chaining and second one is open addressing, mostly used to remove the collision in a data structure. Now we talk about open addressing. Open addressing means is a method for handling collision. Is a method for handling collision. In open addressing, all elements are stored in a hash table itself. We have to use hash table for storing the element. So at any point, the size of the table must be greater than or equal to total number of keys. Not that we can increase table size by copying old data if needed. This approach is also known as closed hashing. This approach is also called closed hashing. This entire procedure is based upon probing. We will understand the type of probing ahead. There is in the next slide we show how the different way of open addressing will work. This is a topic which is discussed about linear probing. In case of linear probing, we discussed already. In case of linear probing, we have to use a linear function to map or store or retrieve the data. In linear probing, the hash table is searched sequentially that start from original location of the hash. If the location that we get is already occupied, then we check for the next location. We start from very first location and search continuously. If the data is not found, we return false. Note, the function used for rehashing follows rehash key n+1 modulus table size. This is the hash function which is used to map the data. This is an example. Let us consider a simple hash function. The hash function is key mod 7 and the sequence of key is, that means the element stored are 50, 700, 76, 85, 92, 73 and 101. This is the table which is initially empty. That means we initially create a table of size 7. The size, the index is starting from 0, 1, 2, 3, 4, 5 and 6. In this case, we have first we have to check the first element is 50 mod 7. The output of this function is 1 because mod return the remainder and the remainder of 50 mod 7 is 1. That means we have to store 50 at location 1. We stored at location 1. 50 is put on location 1. Now the next element is 700. We have to compute 700 mod 7. The output will be 0. That means the element stored at the location 0. So we have to put 700 at the position 0. Now 76 mod 7. The output will be 6. That means 76 is stored at location 6. Now 85 mod 7. The output will be 1 and the output will be 1. 1 placed, that means location 1 is already occupied by 50. So we have to store 85 at the next empty block and the next empty block is second position. So we have to store 85 at second position. Now we have to calculate 92 mod 7. The remainder would be 1 and first position is already occupied. We go on next position. Next position is already occupied. Then we go on third position. Third position is empty. So we have to insert 92 at third position. Now we have to compute 73 mod 7. The remainder would be 3. The element is stored at location 3, but 3 is already occupied. We move on location 4. We have to insert 73 at fourth position and so on. We have to insert 101 at location 5. This is the method through which we have to insert the given element in the data structure. When the same location is identified, because we have to insert 50 at position 1, we have to insert 700 at location 0, but when we want to insert 85, the position calculated position is 1 and 1 is already occupied, then we have to insert at 2 and this situation is called collision. When we want to insert at a position where already data is stored, that situation is called collision. Now challenges in linear probing. In challenges in linear probing, the first challenge is primary clustering. One of the problem with linear probing is primary clustering may consecutive element form group and it start taking time to find a free slot or to search for an element. Secondary clustering means it is less severe to record only have the same collision chain if their initial position is the same. Now this is the second example of hashing, how to store the given value in a table. First draw the empty hash table which will be have possible range of hash value from 0 to 4. That means we occupied 4 places 0 to 3 according to the hash function provided. And now we want to insert a element 50, 70, 76 and 93. According to hash function, we have to insert element in a sequential manner. In case of dating probing, if you observe carefully, then you will understand that the interval between probes will increase proportionally to the hash value. Quadratic probing is a method which we can solve the problem of clustering that was discussed above. This method is also as a mid-square method. In case of mid-square method, we have to use function like this. And this is the iteration method and we use ith slot in the ith iteration. We always start from the original hash function. If only the location is occupied, then we check the other slot. This is a hash function which is used for hashing the element by using quadratic probing. By using this hash function, we have to store the given element in a different position by using quadratic probing. We saw this, the working of this function is so in the next question. This is the example on mid-square. Let us consider table size 7 hash function as hash s equal to x mod 7 and collision resolution strategy to be fi equal to I square. This is the technique which is used to resolve the collision. Insert 22, 30 and 50 in the given slot. Create a table of size 7. First we have to create a table of size 7. Now we have to find 22 mod 7. The first element is 22 mod 7. The value would be 1. We have to insert 22 at the position 1. Now the next element is 30. 30 mod 7 gives 2. That means we have to insert 30 at second position. There is no collision till now. Now if we want to insert 50, the location calculated is 1. Then what will we do? First position is already occupied by 21. Then what can we do? We do like this: 1 plus 0 is square. That means 0 square is 0. Hence there is no change of value. Now second position is 1 plus 1 is square. That would be 2. 2 is already occupied. Now the next position is 1 plus 2 is square. That would be 5. That means we have to use method like this: 1 plus 0 is square. If this position already filled, go on next position. 1 plus 1 is square. If this position is already filled, go on next position. 1 plus 2 is square. That would be 5. And 5 position is empty. So we have to insert 50 at 5th position, because we have to use function for collision is hi equal to I square. So we have to use this index for resolving the collision. Now next is double hashing. The interval that lie between probes and computed by another hash function. Double hashing is a technique that reduces clustering in a optimized way. In this technique, the increments for probing sequence are computed by using another hash function. We use another hash function h2x, hash 2x, and look for the this hash function I multiply hash 2x slot in the ith rotation. This is another method in which we have to use to store the given element or remove the collision in the given data. This is the hash function which I discussed previous also. This hash function is used to store the given data by using double hash function. This is an example. Insert key 27, 92, 72 into the hash table of size 7. That means we have to use a table of size 7. The table like this: 0, 1, 2, 3, 4, 5, and 6. Total space is 7. So we have to take 0 to 6. Now we have to find the value according to first hash function. The h1 k equal to k mod 7. The value of k is 27, and the 27 mod 7 is what? 6. That means we have to store 27 at position 6. Now we have to calculate 43 mod 7. 43 mod 7, the value would be 1. That means 43 stored at location 1. Now 92 mod 7, the 92 mod 7 is 1, and space slot 1 is already occupied. Then we have to mod by, we have to use this function to get the location. 1 plus 92 mod 5. By using this will be gives, this is the 1 plus this will be gives 2, the location would be 3. Now 92 stored at location 2. That means if we want to store an element at a position or a slot, and that slot is already occupied, then we have to compute the position by using second hash function. Otherwise we go according to the hash function 1. This is the method which is used to insert the given element in a table. If any doubt, you comment in a comment box. Thank you. Thank you so much.